going on. All right, so number 8. This is a question about solving equations, and that's something that we were working on yesterday and the day before. So I will get you started on this one. I'll at least get you started so you can see where to go, and then I'll let you finish it. There we go. So if this is our equation, so it looks like m minus 1/3 equals 4/5. Then where should we go? We got m minus 1/3 over here, so how are you going to simplify this, or what do we need to do? What should you do? Trying to solve an equation. Yeah, the goal is to get the m by itself. Right now there's an m minus 1/3 on the left-hand side. And so we use the opposite operations, right, to simplify equations. So if there's a minus 1/3 there, I need to add 1/3 to both sides. So over here, those will cancel out, and I'll just be left with m. And then on the right-hand side, now we have to figure out, well, if I add these fractions together, what do you get, right? Well, can we add these fractions together the way they are? We can't add them together right now because, why? Yeah, they don't have a common denominator. So we need to bring that 5 and that 3 up to a common denominator. So what's the least common denominator between 5 and 3? Yeah, so here the LCD is 15, right? So then this one, what's it going to need? It's going to need a 3/3, right? And what's this one going to need? This one's going to need a 5/5. And then from there you should be able to finish. I mean, it looks like it's possible none of them are correct, but you should be able, if you give it a common denominator, I think you can, I don't know, the correct answer may not be up there. Because one option is none of them. So it is possible on some of these that the answer could be none of these are correct. But that's the process you should follow. So I'm going to let you finish that one, though. Okay? Did that kind of answer your question? Yeah. Okay. All right. Anything else from quizzes that you wanted to take a look at? Yeah. Same one? Yeah. Okay, so then this one's a little different. This is multiplication, the -4 times y. So to solve this one, well, if you have -4 y equals 17, then, well, how do you get rid of the -4? Yeah, we need to divide that out of there. Now, the thing is you need to make sure that if you have negative numbers, you want to, either multiply it or division, you want to take the sign out of there as well. So then these -4s will cancel. Now, all you have to do is you need to figure out, that's the answer. You have to remember, first off, that a positive divided by a negative is going to have to be what? So our answer's got to be negative, right? So we can rule out some answers right away. That right there is in an improper form, and so you may just want to convert it into a mixed number. You could try that first and see by converting it into a mixed number if it was one of those options, or it's possible it might not be on there as well. Okay? But just remember that positive divided negative is always negative. Other ones from that one? Okay. What else? Anything else you want to look at from the quizzes? Okay. So don't forget, take that quiz if you haven't, and then also the homework quiz. That covers everything from the chapter, but it's all fractions. Chapter 4 is all about fractions. Adding, subtracting, multiplying, dividing, and solving equations. If we go over to the practice test, so the practice test covers everything that we've been over so far. So started out, I gave you some order of operations problems, just working with positives and negatives. So, using the order of operations. Then we covered absolute values for a while. Then with, the fractions, operations with fractions. Then there's just the equation solving. So we learned to solve equations with whole numbers, negatives and positives, and then we also threw fractions into the mix. So there will be some equations that you need to solve, as well as translating. So translating sentences either into expressions or equations. So you want to be able to do that. And then the other thing that we mentioned, but these right here, prime factorization and LCMs, mostly we just learned those so that in chapter 4 we could find least common denominators. But I may throw on a prime factorization problem or an LCM problem onto the exam. So that's the content that'll be covered on the exam. So with that in mind, are there any particular problems that you would like to go through today? Because I don't know if we'll get through all of them, so I'd like to prioritize the ones that you want to look at first. Yeah. On one? Okay, so we go number 1, H. So this is a multiplying fractions. I wonder if I think I can just go like that, yeah. So, what's my color? That'll work. All right, so for multiplying fractions, you can go straight across if you want, but this is one of those examples where there's some stuff that can cancel out. So remember, anytime the cancellation, so you can do the cancellation. It only works, though, if you're multiplying fractions. Okay, that's too thick still. Make that smaller. All right, so here, because we're multiplying, we can do that. So what you're looking for is you're looking for numbers in the numerator and numbers in the denominator that share factors. And so here, you've got your 2 and a 32. Those are both divisible by what? 2. Yeah, so 2 divided by 2 is 1. 32 divided by 2 is 16. That's all you got left. Okay. Can you guys see that okay? Really cool. And then 45 and 9 are both divisible by 9. Because 9 divided by 9 is 1. 45 divided by 9 is 5. So all you're left with on top is 1 times 5, and all you're left with on bottom is 1 times 16. You do need to pay attention to the sign, though, because a positive times a negative is always negative. So we know our answer will be negative. So it looks like the result here will just be negative 5 over 16. Okay. You don't have to simplify. You could just go straight through the work, because you could figure out, okay, well, 2 times 45 is 90. 9 times 32 is something, 288. Okay? And a positive times a negative is negative. But then you're going to have to work your way down by reducing. So it'd be like, you could reduce that. Okay, well, they're both divisible by 2, so that could become 45 over 144. Then it just gets a little trickier, because what are both of those numbers divisible by? You could figure out maybe they're both divisible by 9, but you might figure out they're both divisible by 3. It's just a little harder this way, because finding the numbers that they share in common, so maybe you realize they're divisible by 3. So that would be, 15. 144 divided by 3 is 48. Is that true? 48? Yeah, and then at that point, you might realize those are both divisible by 3 again, and that would take you down to 5 over 16, which is the right answer. It's just a little more complicated to do it that way, because it's hard to realize, once those numbers get big, it's hard to recognize that they're both divisible by the same number, especially like when 3s and 7s and weird numbers get involved. So it's a lot easier to cancel ahead of time if you can. Okay? Yeah?
The next one.
Sure. So what happens when we have mixed numbers? What should we do? Yeah, we are multiplying them, but we need to first do what? Yeah, we want to do the conversion. We never really work with mixed numbers in algebra. We always convert them. So 5 times 3 is 15 plus 1. That's 16 fifths. And then 8 times 1 is 8 plus 7 is 15 eighths. So first you want to turn it back into that improper form. Then you can deal with them. Again, it's always nice to cancel ahead of time if you can, because 5 and 15 both share what? A factor of 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. And 16 and 8 are both divisible by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. So all you have left is a 2 times 3 on top, a 1 times 1 on the bottom. So that's 6 over 1, which is really just 6. And that would be your solution for that one. Hopefully these match the solutions I put on the key. I don't actually know. I haven't looked at it this quarter. I made it, I think, last quarter. So, all right. What else? where else you want to go? Because I know you guys all totally looked at this last night, right? You should. What?
Yeah. I don't know the number,
okay.
Letter, but it's, for me it's 21 because I did, it's h minus negative 7, 8.
This one?
Yeah.
Okay. Yeah, you must like copy paste or got some number system or something. That's okay. So then this one is an equation, so that means if it has an equal sign, we should be able to solve it. So this, we should be able to get h by itself, and then the solution will be next to it. This one has one of those situations where I have a minus, and I told you that anytime I see a minus, what do? I just rewrite it as addition. So, because what happens is, you look at that, and then you can think, okay, well, it's minus a minus 8, so should we add a negative 8 to get rid of it, or what does that mean? Then what happens to the sign when it comes to the other side? It gets confusing, but if you just rewrite it as addition, it's really clear that what needs to happen next. What should be our next step? There's a plus 7/8 over there, and I want to get rid of it. Subtraction. So I know that what I need to do here is I need to subtract 7/8 from both sides. That's going to get, so it's like you can forget about how, whatever the sign started out over here, you can forget that equation even existed. Once you rewrite that minus as plus, just work from there, pretend that's the beginning. Then you have this minus 7/8 on both sides. So what we'll have is you got an h on that side. Now we just have to figure out, well, what is negative 2/5 minus 7/8? So we need to combine those two fractions. The problem is we can't. This is like the one that you asked about from the quiz, because they don't have common denominators. So we got to bring them up to common denominators. You always have to go up. So what is the least common denominator between 5 and 8? We're going to have to bring them up to 40. So this first fraction, what's it going to need to bring it up to 40ths? It'll need an 8 over 8, because 8 times 5 will get you up to 40. And the second fraction, what's it going to need? 5 over 5, because 5 is what's going to bring 8 up to 40. All right, so now we just bring those up. So 2 times 8, this will become 16 40ths. And again, my signs are coming through. Don't want to lose those signs. 7 times 5 is 35. Okay, so then we get to that point. And now they have common denominators. Now we can combine them, but we got to remember our rules of negative, working with negatives. So remember, the first number is where you're starting. So you're starting at negative 16, and then you're taking away 35. Where are you going? You're going more negative, right? So really, what do we end up doing here? We end up adding those numbers in the negative direction, because we're starting negative and going more negative. And so this should come out to be like negative 51 over 40. And that would be, that's a perfectly, if I don't ask on an exam, if I don't ask for a mixed number, an improper fraction is a perfectly reasonable answer. I would take that as the right answer. You could convert it into an a mixed number, though, if you wanted, because 40 goes into 51 one time with 11 left over. So it could also be negative 1 and 11 40ths. So, okay. Questions on that one? All right. So a couple tricks, a couple things to remember. Anytime you see a minus, just rewrite it as plus. And then don't just immediately assume because it's a subtraction sign that you should subtract these numbers. Because if you're starting with a negative number and subtracting, you're actually going to end up with a bigger number. It's just going to be in the negative direction. So. All right. What else? Other problems? I can just scroll slowly and you can tell me when to stop. We start from the top. We're going to do some order operation stuff. You guys remember how to deal with absolute values? What do absolute values do? Straight up and down? What do they do? Yeah? They turn values positive? Now, does that mean that this subtraction should become addition? It shouldn't, because absolute values, they're on the order of parentheses. So you take care of them first, but it doesn't change any of the operations outside of the absolute values. So this one, we've got what? 14 minus 8 is that 6? I don't know why that was so hard for me. And then what you need to do is you need to evaluate the absolute values, but the subtraction is going to stay there. So the absolute value of 6, well, it's positive. It just stays positive. And then the absolute value of negative 2 becomes 2. So a lot of times what I'll see is people will want to say, oh, well, that's like minus of minus, so that should become plus. Or it's absolute value, so this should become addition. But that's not true. You take care of the absolute values first, but they don't do anything to any of the operations that are outside the brackets. So this one will actually come out to be 4 for that. Okay. All right. Don't forget that this is another thing that I see really commonly, is 2 to the third power 6. No, it's not. So when you're working really fast, what I'll see a lot of people do is they'll tell me 2 to the third or 3 squared is 6, but it's not. What does 2 to the third power mean? This is 2 times 2 times 2, right? So 2 times 2 is 4. 4 times 2 is 8. So that's going to become 8. So the exponent, don't get too hasty and then, treat that like multiplication, because it's not. It's telling you to take that number and multiply by itself that many times. So 2 to the third power is going to become 8. All right? All right. Do you guys want to see any of these ones? Or you're all feeling really super confident about the test? What's that? You want to go back?
Somebody asked you to do 10 and I didn't see it.
10?
On the other quiz.
Oh, on the quiz?
Yeah.
Yeah, I can go back to that. I'll go back to that in a few minutes. I'll see if anybody has any other on this first, and then we can go back to that one since you missed that one. But I can go back and give you a hand on that one. If you don't ask, I'm not going to do it. It's your time. If you feel confident, you don't have to stay. You could go. That's okay, too. A lot of times, if you run out of questions, we'll just go. I'll stick around as long as you want, though. Yeah, Jay? Which, here? Okay. Yeah, don't forget. So what is a complex fraction actually telling you to do? It's telling you to divide. It's just another notation for division. So there's this line in the middle. What this is really telling you to do is it's telling you need to take 5/8 and divide it by 4/5. Of course, how do you divide fractions? What do you need to do? You got to flip that second. You're going to turn it into multiplication by flipping the second fraction. And so it becomes a multiplication problem. So the complex fraction turns into a division problem, which then turns into a multiplication problem. Do you need common denominators for multiplication? No, you do not. So that's another thing. Don't waste your time on common denominators if you're multiplying. Because not only is it not necessary, but it makes your life so much harder, because then the number that comes out at the end is way big and complicated and annoying. So with multiplication and division, no common denominator needed. You just go straight across. So this would be 25. 8 times 4 is 32. And that would be it. So, and that's not reducible. All right. Yeah. Another thing to notice too is basically what you really end up doing is the fraction on the bottom just gets flipped, right, when it comes up. You said the one right under it? Yeah, so this is like order of operations inside of a fraction. And so your answer here is going to end up being a fraction. Maybe. It might reduce. So order of operations tells us, what do we take care of first? Yeah, we would do multiplication and parentheses and exponents. So in this case, we have some exponents, we have some multiplication. So 8 times 4, what's that come out to be? 32? And then what's 5 squared? Yeah, remember, that's not 10. It's not 5 times 2. It's 5 times itself twice. So that's 25. And then downstairs, so basically you just treat the numerator and the denominator separately, and then you deal with them at the end if it can be reduced. So downstairs you have 3 times 12. So that's 36. Then we're going to clean up the numerator. 32 minus 25, 7? Is that true? So that's 7. And then the denominator is 36. That can't be reduced. So then we're just done. But if you see that where there's like an order, there's stuff on the numerator, stuff on the bottom, you just treat them separately until the end. Once you come down to a number on top and a number bottom, then you can deal with that as a fraction. You know, it might be able to be reduced. It might be divisible or something, but that's how to work that one. Okay. Anything else here? Adding.
On in right there, would you just rewrite that as 2/5 minus?
Definitely. Yeah. Anytime you see that plus or minus, you just rewrite it as subtraction. These two to combine them, though, they need what? Yeah, you got to bring that denominator up to 45 because you can't subtract without an LCD, right? So you got anytime you see plus a subtraction or addition of fractions, don't go straight across. Okay, that's like the biggest no-no in math, right? It's like if you just add straight or subtract straight across, it'll drive your math teacher insane. They'll just want to like tear your paper apart and just say no. Okay, don't add and subtract straight across. You have to have least common denominators. So this one, what do we need to give this one? A 9 over 9 to bring it up to 45ths. And then this one needs a 5 over 5 to bring the 9 up to 45ths. So this one will become 18 over 45. This one will become 25 over 45. Then we can do the subtraction. So 18 minus 25, that's actually going to take you negative, right? If you start at 18, you subtract 25, you're going back to negative 7 out of 45. That's your solution there. So, yeah?
Can you do the second to last one?
Down with the prime factorization one?
Yeah.
Yeah. So there's all the equations solving. For prime factorizations, I usually use trees. And I try to divide out the biggest thing I can as possible, especially like 1050. I know that thing's divisible by what? Maybe, is it 20? Is it divisible by 20? I don't think. Oh, you said 5. Yeah, 5 will work for sure. You can go even bigger. If it ends in a 0, it's got to be divisible by what?
10.
Yeah, so if I see something like that where it ends in a 0, I know for a fact I could just divide the 10 out immediately. That brings it down to a lot smaller numbers. And then 10 is 2 times 5. 105 is divisible by 5, so then you could take the 5 out at that point. 105, if you divide the 5 out, it's 5 times 21. And then 21 can be broken apart as 3 times 7. And so your prime factors, they sit at the bottom of the branch. So we'd say that 1050 can be written as 2 times 3 times 5 times 5 times 7. That's the prime factorization. So it can't be split apart any more than that. All right? What about this one, 5? How do you do LCMs if they're big, nasty numbers? Yeah, the factor tree, that's what it's really useful for. It's not just like arbitrary knowledge that you, I mean, maybe outside of a math class it is, but it's not, within a math class, it's not super arbitrary knowledge. It's useful. You can, to find the least common multiple of two numbers that are not so simple, we use the tree, right? So 210 is like 10 times 21, and then 10 breaks apart as 2 times 5. 21 breaks apart as 3 times 7. Okay, so you break that number down first, and then we can do the same with 18. 18 is 2 times 9, and 9 is 3 times 3. So you look at the prime factorization. So 210, look at the bottom of the tree. It's 2 times 3 times 5 times 7. Right, I'm looking at those numbers. And then 18 is 2 times 3 times 3. I'm looking at the bottom of the tree, right? And now, to build the least common multiple, first you look at what they share in common, right? So they both have a 2, so that's got to be in the least common multiple. They both have a 3, that's got to be in the least common multiple. They don't share anything else in common, so you just have to throw everything else in to make it divisible by those two numbers. So it needs another 3 to be divisible by 18. It needs a 5 and a 7 to be divisible by 210. And then you can just multiply that out to get the least common multiple, and that's going to come out to be like 630. Okay. Okay. When you're taking the exam, I do give partial credit. So if you give me the right answer, I just assume that you got it. You didn't cheat to get it. So if you give me the right answer, you don't have to show work necessarily. But if you give me the wrong answer, I'll look at your work and you can earn partial credit. So it's always good to show as much work as possible, just in case you get the answer wrong. Then I can go back and track it. It's like, okay, did you actually understand what you're doing? Maybe you just made a little mistake, lost a negative sign. That's not a big deal. I'll give you most partial credit for that. So, all right. What else? Any of these? So, typically I just go till you guys stop asking. If you want to stick around and look at more examples, you can. If you don't feel like you need to stick around and look at examples, then you're welcome to go. I'll stick around though as long as you want. It's up to you. If you turned in one of these yesterday, you can also grab it on your way. I missed somebody's name though, so you might want to check. If you turned it in yesterday, check your Canvas gradebook and see. I'm missing somebody's name, but somebody turned one in without a name. I don't know who that was, but I know Joel, your name was on yours. It's in here somewhere.
Is it last one because I turned it over?
Maybe. It sure is. Good call, Joel. And Kenya, your name was on one. And Rebecca, true? It's Rebecca, right? Mm-hmm. Okay, yours was, did see your name. Charlie, saw your name. Here somewhere. It's right next to Kenya's. Where'd it go? There we go. Piper, true. All right. I know yours is in here. Yours. And it is Lahana. Yours. I haven't learned your name yet. I'm sorry. Shirley. Maybe yours was the one. No, you're right here. Shirley.
I wrote my name on it.
Shirley. Destiny.
Yeah, I have a good feeling I might have been the one.
No, your name was on it.
Sweet.
All right. Yeah. Yeah, so if you didn't get the sheet from yesterday and you just want to look, you want to see what it says, I always keep extra copies. I'll just put a copy. But if you did want an extra copy of what we did yesterday, you can grab it. So you wanted to go back to 10? Yeah, we can go back and look at that real quick. Which one? Yeah, the phrases? Yeah. We'll do an example of that. Let me just real quick. I'm just going to hop back here and show you what you were asking about. The quiz for number 10. This one?
Yeah.
Yeah, so basically, so there's a -4 right here. And so it's -4 times y. So you need to divide both sides by -4. Right? To get that -4 out of there. Now, a positive divided by a negative has got to be negative. But you may want to check because I have whole numbers and mixed numbers. So this may be an improper fraction, and you may be able to convert it to a mixed number. So that might be the trick. And then if you convert it into a mixed number and the answer's still not there, then the answer's probably none of those. But it could be. It's not due yet. Some people haven't taken it yet. But it could be. Seems likely. Yes. Yeah, back to the.
Thank you.
Yeah, sure. Sure. So you want to look at some of these?
Yeah.
Yeah. Just start at the top, or maybe here.
Yeah.
Sure. So it says translate to equations and solve. That means there should be an equal sign in these. So 5 less than. So less than tells me that we should be doing what? Subtraction. Now you got to be really careful because we're taking 5 away from x. So when it says that, it actually gets written in the opposite order. 5 less than x, that means take x and minus 5. So it's x minus 5 means equals 21. Those are the trickier ones because you want to put them in order. You want to do 5 minus x, but because it's 5, just because of the way it's phrased, it actually ends up getting flipped into x minus 5 when you translate the equation. Normally, you can kind of just like read straight across and write stuff down. Now, to solve this, though, so what I got minus 5 there, so what do? I would just add 5 to both sides. So that would get rid of my x there. And then 21 plus 5 is 26. And so that would be the solution to that one.
So would it be like x always first, comes in first, or out?
Yeah, for the sake of this test, probably. Yeah, you can have equations where the variable comes second. We haven't really dealt with a lot of those. So as a rule of thumb, yeah, you could probably assume the variable should come first. Yeah. Here, again, and like it's not as complicated. Like sum means what? Addition. And addition, the order actually doesn't matter. Subtraction, it does. But, you can read it left to right. The sum of A, the and basically tells you where to put the addition sign. A and 7, so A plus 7 means equals 36. So, and then how would you solve that one? I got to subtract 7 from both sides to get rid of it on the left-hand side. So it's gone over there, and you just be left with A equals 36 minus 7 is 29. Your solution there. Yeah. The difference one is the trickier one. What is 3 times? I mean, that's pretty straightforward. That's multiplication by 3, right? So 3 times, wait, that doesn't even make sense. It should have just said that. I think that's what I actually meant for it to say. You can just ignore that one. But that's how it was supposed to read. I need to fix that. I meant for it to read, 3 times a number and y. That's like there's some other number involved, but that's not how it should. It should have just said 3 times y is 39. That's what I meant for it to say. And then how would you solve that? Yeah, you divide both sides by 3, so your answer would be 13 in that case. This one's similar. What does product mean? Product is another word for times. Yeah. So, yeah. I don't know. So I don't know if you know this. It's not super relevant, but just for vocabulary wise, like if you 6 times 5 is 35, right? So, no, it's not. It's 30. But these right here, these are called factors. So like when we say factor trees, because we're breaking it apart into the factors, the number that comes out is called the product when you multiply. So that's why the word product is synonymous with multiply, because the number that comes out of multiplication is called the product. So the product of -6 and, remember the and tells you where to put the sign, is -42. How do you solve that one? Yeah, you're going to divide by -6. Don't forget the sign, because you want to get that sign out of there. All right, so you're just left with y equals. Then 42 divided by 6 is 7. A negative divided by a negative is always positive, so you're done.
So if it was p less than 8, it would just be the same thing?
No, but I wouldn't write it that way. Because you this is p less than 8. That's saying that you're taking p away from 8. But 8 less. That's why the less than thing is weird, because it's like it's like you're flipping it. Because what I'm really doing is that sentence is telling you what you're taking away first, and then it's telling you what you're taking it from, and so it flips it. So it's like if you're there, because there's 2 ways you could phrase this. You could phrase it that way, but you could also say the difference between. But if you're going to say the difference between, I'm not telling you what I'm taking away first, I'm just telling you that there's going to be subtraction, you would flip it. So these 2 phrases, they say the same thing, but it's just because of the way that English works. if I'm saying 5 less than 10, I'm not talking about a negative number, right? I'm talking about 10 minus 5. So it's just the way we talk. But if I'm telling you the difference between two numbers, I'm telling you you're going to subtract, then I would give it to you in order. Yeah.
How many questions are there going to be?
I don't know. I think there's 20.
Can you scroll up
Mm-hmm.
about the longer?
How long is it gonna be?
Well, I mean, I write it to. Most people won't take an hour. I try to write it to take less than an hour. Yeah. So this is a little longer than a regular exam. The practice is. So just to finish this one, how would you finish that one? Yeah, add 8. But if you add negative and you add 8, what are you actually going to do? See, negative 14, I'm adding 8. I'm getting closer to 0, so we're actually subtracting. So 14 minus 8 is 6, but it's going to stay negative because we started negative and we didn't make our way back to 0. Okay. You want to scroll up, Troy? Yeah. Which one? Was it
Kind of like those. Those ones are.
this one right here, like the fraction one?
Yeah.
So first thing, anytime you see mixed numbers, what should you do?
You have to times it and then add it.
Yeah, we should convert it to a improper. That should always be step 1. So 10 times 2 is 20. 20 plus 3 is 23. And our denominator stays the same. It's 10.
I would have done it over 1.
No, yeah, so you don't change the denominator when you're converting. It stays whatever it was to begin with, because everything is still in tenths. Yeah. What's really going on, because what's really happening here, and you don't have to write this down, but what's the reason this happens is because this is like 2 plus 3 tenths, right? But to combine those into one fraction, you would need a common denominator. So this 2, this is like 2 over 1 plus 3 over 10. And the 2 would need a common denominator of 10 to combine it. So what do you end up doing? 10 times 2 is 20 plus 3 tenths. So it's 23 tenths if you're trying to put it into one single fraction with a common denominator. But the shortcut does it faster. It's just 10 times 2 is 20, and that's the common denominator step. And then you add the 3 because that's left. So it's 23 tenths. But it stays in tenths. And then here, 4 times 1 is 4, plus 3 is, and so but it stays in fourths. So 7 fourths. Now, you can't just subtract yet, though. Why? Yeah, the denominators are not the same. So we got to bring them up to something that is the same. And 10 and 4 are the lowest common denominator is what? No, you got to go up. You can't go down. You got to go up for LCDs. So what's the LCD between 10 and 4? You could take it up to 40. That'll work. But there's actually a number that you could go lower. 20. Yeah. Now, it just makes it more complicated. I'll show it to you in a sec. So first I'll do it bringing them up to 20. So 23 over 10, that's going to need a 2 over 2 to bring it up to 20ths, right? Because 10 needs a 2 to bring it up. Because you're trying to figure out, I've got a 10 right there. I want to bring it up to 20ths. So what do I need to multiply that 10 by to get it up to 20ths? It's got to be 2. But if you do it on the bottom, you got to do it on the top. That's why we do the same number bottom top. And then what about this one? What does 4 need to bring it up to 20ths? It needs a 5, so this one's going to get a 5 over 5. And so 23 times 2, that'll become 46 over 20. And then 7 times 5, that becomes 35 over 20. And now we can subtract. 46 minus 35 is 11, and the common denominator doesn't change. Okay. Yeah. Now, let's say you did bring it up to 40ths. That's not a problem. So let's say you gave this one a 4 over 4, and you gave this one a 10 over 10. That's fine. This would be, 23 times 4? That would give you 92 over 40. And 7 times 10 would be 70 over 40. when you subtract those, 92 minus 70, you're going to get 22 over 40. But what's true about that fraction? It's reducible, because if you divide the top and the bottom by 2, what do you end up with? It just gets you back to 11/20. So if you take it up to a number that's not the LCD, that's okay. It's just that your fraction at the end is going to be reducible, and then it's just going to drop back down to the LCD. Yeah. So using the least common denominators just keeps the number smaller. It's kind of like with it's like multiplying fractions. You can reduce in advance, or you can reduce at the end. It's the same thing here. You can go up to a big common denominator, but if you get the least one, then it just makes your life a little easier. So, okay. But the key here is anytime you see mixed numbers, don't even deal with them. Just immediately turn them into impropers, because mixed numbers are just a pain. Yeah. Okay. Same thing. Yeah, same thing here. If we got a mixed number, I'm just going to use the trick. So 3 times 8 is 24. 24 plus 2 is 26. It'll stay over 3. And then I got divided by 12 times 1 is 12. 12 plus 1 is 13 over, and it stays 12ths. Now, what happens when you divide fractions? We don't ever really divide fractions. We end up multiplying by the reciprocal. It's always the second one that flips, right? Yeah, always. Yeah, so if you're dividing fractions, you have to flip the fraction, and you always flip the one after the division symbol. Okay. So basically, we never really divide fractions. We always just rewrite it as multiplication.
And then you go straight across.
And then you go straight across. If you can simplify, though, like this one simplifies, because 3 and 12 are both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And 26 is actually divisible by 13. 26 divided by 13 is 2. 13 divided by 13 is 1. And so you're actually just left with 8 over 1, which is just 8. If you did, and like you said, that you could just go straight across. If you did go straight across, well, you just get big numbers. That's the thing. Because 26 times 12, that's, what is it? 312. 312, and 3 times 13 is 39. Yeah, but if you actually did this in your calculator, pull out your calculator, do 312 divided by 39. What do you get?
8.2.
Wait, then that can't be right.
Oh, wait.
I was going to say, it should come out to 8.
Yeah.
Yeah. Mm-hmm. So you just get back to the same answer. It's just that you end up going up to bigger numbers to get right back down to the small number. So that's why doing the reduction.
Still, like, if I did it that way, it would be wrong.
Well, this answer right here would be wrong. Yes.
Yeah.
But if you reduced it down to 8, that would be right. Does that make sense?
And you can use calculators.
Sure. Yeah. So you can use your calculator, but you can't use like a scientific calculator.
Yeah.
It has to be like a Casio or a basic calculator. Like, you have the Casio right there, the black one?
Sure.
Oh, okay. I thought it's right here. That one, the black one, that Casio from the bookstore. You can use one like that, but you can't use like a fancy one. Yeah. Okay. All right. Anything else you want to take a look at? Yeah, from this section?
Yeah.
Wait, that one or?
Yeah, that one.
Okay.
Would I need to change the denominator?
No.
No.
No, because what happens is if you're multiplying or dividing, you don't have to worry about common denominators. The only time you're going to need common denominators is when you add or subtract.
Oh, okay. I've actually been.
Yeah. So this one, you can go, so this one, you could actually just go straight across. That's what I was showing right here, is that you could just do 2 times 45 is 90, and 9 times 32 is 288. But then you need that's reducible, so you need to work it down. Or if you cancel ahead of time, 32 is divisible by 2. 32 divided by 2 is 16. 2 divided by 2 is 1. And then 45 and 9 are both divisible by 9. 45 divided by 9 is 5. 9 divided by 9 is 1. So you're just left with 1 times 5 on top and 1 times 16 on the bottom. So you'll get the right answer either way. But you don't have to worry about common denominators when you're multiplying. Okay. All right. I'm going to stop my recording now since we're dwindling a little.